Hello everybody and welcome to your 32nd and 33rd chapter in your Java EE 7 tutorial series. In this tutorial we'll be talking about Enterprise Beans and how they're Java EE's components that implement Enterprise JavaBeans technologies. Enterprise Beans run in the EJB container, a runtime environment within Glassfish server. Although transparent to the application developer, the EJB container provides system-level services such as transactions and security to its Enterprise Beans. These services enable you to quickly build and deploy Enterprise Beans, which form the core of transactional Java EE applications. So getting into it, let's talk about what is an Enterprise Bean. An Enterprise Bean is a server-side component that encapsulates the business logic of an application. The business logic is the code that fulfills the purpose of the application. Now, a few benefits of Enterprise Beans. 1. Developers don't have to worry about system-level problems, like transaction management and security authorization. This allows them to focus on business-related problems rather than these low-level problems. 2. Most of the heavy lifting is done by the EJB container, which makes building the client's presentation side much easier. Imagine creating a website for the client and stopping to code for every single business need. This offloading to the EJBs makes the clients thinner and faster, which is especially useful on smaller devices. 3. Enterprise Beans are portable components, making coding on other similar applications much easier on the developers, so they don't have to start from the ground up again. Instead, they can reuse EJBs that they've used before. Now, when is an Enterprise Bean useful and when it works best? So, Enterprise Beans work best when the application must be scalable. The growing numbers of users are easily handled with Enterprise Beans because it is very easy to distribute it across multiple devices. When transactions must ensure data integrity, transactions could be lost if sent at the same time, and EJBs can handle such transactions safely. Or when the application will have a variety of clients. If your business has to handle people from multiple regions, EJB can help out with that. Now, there are a few types of Enterprise Beans. There are two types, which we'll be talking about. Session EJBs, which perform a task for a client. Optionally, it may implement a web service. And a message-driven EJB, which acts as a listener for a particular messaging type, such as the Java Messaging Service API. So what is a session bean? A session bean is like a diligent worker for you. It tries to make do with the business logic that you requested from it as quickly and efficiently as possible. It even shields you from the complexity of what's going on in the background to enhance your experience with the application. Now, there are a few types of session beans. There are three, which are stateful, stateless, and singleton. Now, stateful session beans are session beans that have a one-to-one conversation with its client. This means that every stateful session bean will have a client that quote-unquote owns them. Each stateful session bean will listen to its owner's requests, do the request, and then wait for the next request. Stateful session beans are useful when a client needs to hold information about an interaction, or the need for a client's bean to be ready to go is top priority. So next, there are stateless session beans, which in contrast does not have a specified owner, but instead takes requests as they come. Clients ask a request of this bean, get the response, and the stateless session bean moves on to the next request. The lack of a restriction on stateless session beans reduces the number of session beans needed, but it is often a little slower as each client does not have their own session bean to do their tasks. These are useful when you need more performance, when clients don't need the bean to hold data, when performing generic tasks like verifying an email, or implementing a web service, which is not possible through stateful session beans. Now finally, there are singleton session beans, which are similar to stateless session beans in their ability to serve any client, but with one key difference. With stateless session beans, there can be a pool of beans serving multiple clients, but with singleton session beans, there is only one bean serving one client at a time. This may sound foolish at first, but there are advantages to using a single bean to do a client's bidding. First, you never run into concurrency problems, and they work great when managing the startup and shutdown of the application. They're useful when performing sensitive tasks that should not be mixed up, again due to concurrency issues, and they can implement a web service as well. So now let's take a look at our message-driven beans. A message-driven bean is an enterprise bean that allows Java EE applications to process messages asynchronously and is a very popular bean for the job of JMS listener. A message-driven bean receives messages from the Java EE components, EJBs, application clients, web components, or other systems. So what's the difference between message-driven beans and session beans? Well, the biggest visible difference between these two types of beans are the way that they're accessed. Session beans can only be accessed through their interfaces. Meanwhile, message-driven beans do not have an interface and are accessed through to them directly. So what do message-driven beans do? Message-driven beans are similar to stateless session beans in the way that they can be activated by any client's message and they do not need to hold any data or any conversation with the client, which the stateless word means. Message-driven beans activate when a message is received. The beans on message method is called to process the message, and then the on message method can call helper methods or other session beans to process the message. Otherwise, the method could also be stored in a database. So to access enterprise beans, a little note here, the material here applies only to session beans and not to message-driven beans because they have a different programming model. Message-driven beans do not have interfaces or no interface views that define client access. Once again, this is only for our session beans. So clients can access enterprise beans through two ways. Either a no interface view, where there's public methods put all about where it's you can like put your hand in and then pull out any method you want. And then there's the business view, which is basically a bit more closed and making it more constrictive. But sometimes this can be a good thing, especially if you don't want some methods to be, like you don't want people to be like delving into your code. These views simplify the development process and maintenance of these AJBs. Not only do the interfaces shield the client from the complexities underneath, but it can also protect them from getting affected during the changes to the enterprise beans. So, using enterprise beans in clients. The client of an enterprise bean obtains a reference to an instance of an enterprise bean through either dependency injection, using Java programming language annotations for applications that run inside the Java EE server managed environment, or JNDI lookup. So, this JNDI lookup, it just means Java naming and directory interface syntax to find the enterprise bean instance. These are for applications that run outside of the Java EE server managed environment. Just so you know, the Java EE server managed environment is literally just your Glassfish server. That's it. So when you design a Java EE application, one of the first decisions you have to make is the type of client access allowed by the enterprise beans, either remote, local, or web service. Local access is most useful when you have many beans that are tightly coupled, like a bean that processes sales and another bean that emails a confirmation email to the client. Having a local access can improve performance in these conditions. An example of this would be when playing an offline game like Flappy Bird on your phone only communicates with the server in the game and displays what is shown. Next, there is the remote access, which depends on your type of client. If an enterprise bean is accessed by application clients, it should allow remote access. In a production environment, these clients almost always run on machines other than those on which your Glassfish server is running. For example, when you use the Spotify app on your phone, it is remotely talking with a Spotify server on the other side of the world to play your songs. Now, both of them have a boost in performance. Owing to such factors as network latency, remote calls may be slower than local calls. On the other hand, if you distribute components among different servers, you may improve the application's overall performance. Finally, there is the web service, which accesses a Java application in a different way from local and remote accesses. What they do is they use web services, which basically, it's like the difference between going into the Spotify application on your computer and going to the Spotify website on your computer. The website can talk with anybody, but like the remote and local accesses have to be built in, like the code that they're using. They have to be able to talk with each other. But web services are like, they're evergreen. Like you don't need to worry about them like going like getting outdated, because web services are always able to communicate with any server or any client on the other side. As you can see, both accesses have their own strengths and weaknesses. But if you aren't sure which type of access an Enterprise Bean should have, choose remote access. This decision gives you more flexibility. In the future, you can distribute your components to accommodate the growing demands on your application. So let's take a look into the contents of Enterprise Beans. To make an Enterprise Bean, you need the following. You need an Enterprise Bean class, which contains the business logic of the application and implements the business interfaces. Business interfaces, which define the business methods implemented by the Enterprise Bean class. A business interface is not required if the Enterprise Bean exposes a local, no interface view. And finally, there's helper classes. Other classes needed by the Enterprise Bean class, such as exception and utility classes. Finally, let's wrap this presentation up with the life cycles of Enterprise Beans. So first of all, let's take a look at the life cycle of the stateful session bean. First, you gotta create, inject any dependencies, call back any post constructs, and then initialize your EJB. Basically, what happens is your EJB does not exist, and then it's first created, injected anything you need, constructed any callbacks. Maybe you've created an EJB before that's similar to this, and then you initialize it, and then you make it ready. Then you can do something which is basically to passivate, which is like setting the EJB to go to sleep when it's not being used. Since every client has its own like EJB, all of them won't be used at the same time, right? So that's why passivation is super useful, because let's say like this bean isn't being used, so we can put it to sleep until it's being used again. Once it's done, you can then remove it and then do any pre-destroy commands and then make it into not existing. Next, there's the lifecycle of stateless session beans and singletons. So first of all, stateless session beans inject any dependencies and construct anything, like if you created this EJB before. This does not need to be passivated just like a stateful session bean, because this session bean will be constantly active. And then once it's done, you can then destroy it if you wish so. The reason why I combined this with a singleton session bean is because a stateless session bean is literally like more than one singleton session bean. And a singleton session bean is just one of these beans. That's it. Finally, there's a life cycle of a message-driven bean. So here, all you got to do is do your injections, your post constructs once again. And what you got to do is then you got to create your bean, and then you set it to being ready. And then what it does is it calls its on message command on itself again and again. Once it's done, it then pre-destroys itself, and then it goes back to not existing, and the cycle continues on. So let's take a look into an example, our converter example. Now that we're in our NetBeans, let's go ahead and open our project, and let's make sure that you navigate to your EJB, and then you go down to your converter. Go ahead and open that project up. This example shows how to deploy, develop, and run a simple Java EE application named Converter that uses an EJB for its business logic. The first thing that you want to see is, first of all, let's take a look at our, our converter bean.java. This is the bean class for the converter bean Enterprise Bean. All this is doing is, this is our stateless session bean, which takes in the rates. So you apply the rates, and and then it sets the dollar amounts of yen and the dollar amount of euro. Next, there is our web servlet. This servlet is simply just a process hub. It processes your data and it takes in, and then it sends it to your EJB. This EJB then gives you the methods that it's going to be using. And then this guy uses those methods to then print out the yen and the euros. So once you got that, let's go ahead and check this converter out. Let's go ahead and make sure that our Glassfish server is started. In my case, it is. And let's go ahead and build it. So the purpose of this converter is to calculate currency conversions among Japanese yen, euros, and US dollars. The converter application consists of this Enterprise Bean over here, and a web client, which is our servlet here. So going into here, you can right click and click run. This will go ahead and deploy our converter. And then you can see right here in this tiny little area right here, you can enter a dollar amount. Let's go ahead and put $10. And we can go ahead and submit it. Now what this is doing is it's submitting this $10 into our servlet. And then our servlet is then processing it and then telling us that this will then go into our methods over here, which converts your dollar to yen, which it then converts right here and prints it out. And then what it does, it converts your yen into euro, which it does over here. As you can see, our conversions are right over here. Our conversion from a dollar amount to a yen rate is this much, and a yen rate to a euro rate is this much. So now that you got that, let's go ahead and try to, change it up. Let's say that the euro rate drastically decreased and it went to 1. So let's save that and let's go ahead and build it once again. What this is doing is, what we're doing is we're modifying this euro rate, and then now once we're redeploying it, we can go ahead and check it back in our thing. It will be different. So let's go ahead and run this guy again. And if we put the same $10 and submit it, you can see that this number has changed now. Now, instead of changing, this yen and this euro is the exact same conversion rate instead of the 0.007 conversion rate. And that's basically it. That's it about the converter. And that wraps it up for today's tutorial, everybody. I hope you understood why Enterprise Beans are incredibly amazing, because they're literally the backbone. They're what makes Java EE tick. They are the business logic and what makes businesses so crazy about Java EE. Alright, so now that you get that, I will see you in the next video where we'll be talking about more Enterprise Bean examples, because I know that that one example was not enough. Let's take a look at a few more in the next tutorial. Until then, I will see you in the next video.